In this video, we're going to take a quick look at how Carl Gauss figured it out, which was pretty ingenious. So we did it with this loop and just powering it 1 plus 2 plus 3 plus 4 plus 5 plus 6, etc. With Gauss, he did something like this on his chalk tablet, and he said, the sum of the numbers, S represents the sum of the numbers, is 1 plus 2 plus 3 all the way to 100, and then brilliantly wrote it out the sum again from 100 down to 1. And if you do that, you can notice that if we decided to add these things together, so let's put a plus sign here. All right, I'm going to take S plus S, and let's see what we get. So S plus S is 2S, okay, 2S. And what 2S equals, well, when I do add up each of these columns, right, these numbers all line up here, 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 98 plus 3 is 101. So we get 101 plus 101 plus 101 plus, plus dot dot dot, 101 plus 101 plus 101. Okay, that's pretty cool. So 2S equals, well, how many of these 101s do I have, right? Well, there's 100 numbers. So I have 100 101s. Well, we can figure that out by going 100 times 101. Okay, that's pretty brilliant. That seems like a lot faster than having to do all of this. And then, but that's twice my sum, so we just need to divide by 2. So my sum is 100 times 101 divided by 2. Okay, which would be, like 50 times 101, which gets us our 5,050, which is a lot. Like, that's how quick he did it, right? He didn't have to do all these sums. He turned it into multiplication and division. Okay, that's pretty cool. Just pause for a moment there and just be like, wow. Okay, good pause. All right, now let's just abstract it a little bit. And then we're going to do the same thing. We're going to say, well, what if we had 1 to n? Right, where n is any number. I start at 1, but I go to any number. What could I do here? Well, same type of idea. We're going to get 2s, right? If I add these things together, 2s will equal, well, what do these columns add up to? 1 plus n is n plus 1. n minus 1 plus 2 is n plus 1. n minus 2 plus 3 is n plus 1. So again, we get n plus 1 plus n plus 1. I'm actually going to skip a step here. We get n plus 1 all the time, and we have 1 to n. So we have n values of n plus 1. And then, of course, we do that last step where we would divide by 2. So n divided by 2 times n plus 1, like so. Okay. I think I can't, well, I'm not going to play around with fractions and stuff now. There's some math stuff here. Ooh, measurement tools. Anyway, we could do n like this and have the divided by 2 at the end as well, or write it as a fraction, right? This whole thing over top of 2. Okay, so that's a calculation that we need, n times n plus 1 divided by 2. So if I go back to my code, instead of doing this stuff here, this loop, let's comment that out. What I could just do is go let total be assigned n, which in this case is 100, right? 100 times n plus 1, which is 101, and then divide by 2. And we saw before that the sum was 5,050. If I solve this problem this way, I should still get 5,050. Right? Again, if I wanted to change this to 1,000, right? 1 to 1,000. If the n is 1,000, 1,000 plus 1 is 1,001 divided by 2. And we should get that 500,500. Okay, so instead of using this loop, we can use this calculation. Now, what's the big deal, right? We got the answer before with the loop. That's awesome. I wanted to show you this because it's cool. Like, it's pretty awesome how he came up with this strategy, but also to get you thinking about efficiency, right? On a small program like this, our computer can totally handle looping and actually does a really good job. But as this number gets larger and larger, or as our program gets more complex and has to do more operations, you want to make sure it's efficient. And I would suggest that doing this calculation, right, we just have to multiply and divide, is going to be a lot more efficient than looping 100 times and adding and storing into a variable, right? So in terms of what we're getting our program to do, our computer to do, this loop is a lot more work than it would be to just do this calculation. Okay, so knowing a little bit of math would help you and make um, this program a lot more efficient. Okay, anyway, just wanted to get you thinking about that and share that with you. That is it for the story of Gauss. Hope you're seeing the power of loops. All right, take care and see you in the next video.